In this video, we're going to be introduced into a piecewise defined function. And a piecewise defined function is exactly as its name implies. It is a function that is defined by more than one equation or piece on different parts of its domain. So a piecewise defined function is basically going to have more than one definition, and that definition is going to change depending on which piece of the domain that we are looking at. So let's look at an example here. Actually, before we look at this example, let's talk about maybe a real life scenario that you've had to deal with in your life. And I know this is a little less common in these days, but back in the day, 20 years ago, when texting first came out, when you bought a texting plan, you didn't get unlimited texts. Instead, you paid a flat fee of maybe $5, and then you got 100 texts. Well, every text that you made over that 100 in the same month, you had to start paying per text. So that would be an example of a piecewise defined function, because the amount of your bill would be $5, the flat rate between 0 and 100 texts. But once you got above 100 texts, then you would start paying the $5 plus so much per text. And so that is a real life example of where a piecewise defined function might be used. So the amount of the bill is $5 from 0 to 100, but it's going to be $5 plus so much per text from 101 and above. So that would be a real life example of a piecewise defined function. And sometimes our piecewise defined functions will have two pieces, like the example we just defined. They might have three. You could even have one that had 6 or 7 different pieces. Now, we're not going to work with anything like that in here, but just so that you're aware, those could possibly exist because we can define it as many different ways as we need to in order to make it work for our specific scenario. When we are working with a piecewise defined function, we're going to evaluate it in a very similar way that we've evaluated functions all along. But one difference is we have to figure out which piece of the function to plug our values into. So previously, if we had something like f of x is equal to 2, I'm sorry, f of x is equal to 2x, and we were asked to find f of 3, well, we just plugged 3 in for x and simplified. So f of 3 would be 6. Well, we're going to use this same concept in piecewise defined functions, but the difference is, do I plug it into the top piece, the middle piece, or the bottom piece? And that's what we have to decide based on the domains that are provided. So if you notice over here to the right of each of our definitions, we have a domain for x. So if x is greater than or equal to -1, but still less than 1, then we're going to use this piece of the definition. If x is 1, then we're going to use this piece. And if x is greater than 1, we're going to use this piece. So these values of the domain are going to help us identify where to plug in the value we've been given. So let's start with f of 0. So the x value in this case is 0. So we figure out, where does it fall into the domain? Is 0 between -1 and 1? Is it equal to 1? Or is it greater than 1? Well, hopefully everybody recognizes that 0 falls between -1 and 1. So that tells me that for f of 0, I'm going to plug it into this top piece of definition. So I have -0 plus 1. Well, 0 can't be negative, so it's just 1. So in this case, f of 0 would be equal to 1. Now let's look at f of 1. Well, f of 1, again, we have to figure out, where does it fall into the domain. So we come up here and we say, okay, is it between -1 and 1? Is it equal to 1? Or is it greater than 1? Well, hopefully everybody recognizes that 1 is equal to 1, which means that we will use the middle piece of definition to evaluate f of 1. And you'll notice there's not an x in that middle piece of definition because regardless of x, if it falls here, then the output is simply going to be 2. So f of 1 is equal to just 2. And then last but not least, let's talk about f of 2. Again, we need to figure out where does 2 fall into the domain of the function. Well, it's not between -1 and 1. It's not equal to 1, but it is greater than 1, so we're going to use the bottom piece of definition to evaluate f of 2. So we plug 2 in for x, and we get 2 squared is equal to 4. So when we're working with a piecewise defined function, it's important to make sure that we plug our values in to the correct piece when we are evaluating. Now, the last thing that we want to do here is to determine the domain of the entire function. Well, remember that the domain for each individual piece is given over here on the right, and the domain for the entire function is all of these combined. So a lot of times people like to see this visually and it helps them to figure out what's going on. So we're going to plot each of these on the same number line, and then we'll look at them as a whole, and that will help us determine what our domain is for the entire function. So if we look at this first piece up here, it includes everything from -1 until 1, but notice that it does not include 1. So it includes -1 because it's equal to, and it includes everything between there, but it doesn't actually include the 1. However, the middle piece includes 1, so we can include it now, even though we couldn't with this top piece. And then what does this piece do? It includes everything that's greater than 1. So between the 3 pieces of definition, essentially the domain covers everything from -1 all the way up to infinity. So the domain of the entire function f would be from -1 to infinity. And because we're including -1, we use a bracket around it. We're not including infinity, so we use a parenthesis around that.